Well, welcome back, everybody. But we are back for the Structures and Systems track, and you're already to session number 3 out of 5, so you're doing great. This is about designing and building with advanced materials. Now, everything that we've been talking about is kind of about advanced materials. Remember, the first session we had was about kind of advanced roofing systems and advanced insulation and structural systems. The second track that we had then this morning was kind of what advancements in electrical systems, specifically switching and smart controls. But this one is kind of go a little bit farther out there on the edge, which is really about how do we potentially get away from traditional stick built? You know, buying a bunch of lumber, dropping it in the mud, sorting through it, and building a home right out there in the field. Are there alternatives to that? And are those alternatives potentially going to give us an advantage and really lead us into kind of a brave new world in home building? We've got several panelists up here with us today, so I'd like to introduce them to you. The first presenter today, Paul Cardis. I've known Paul for many years. He's no stranger to this industry whatsoever. He's got a new startup. He had an old startup before that was very successful, but he's had a new startup now on 3. But a bunch of his clients are involved kind of in playing with some of these advanced manufacturing techniques, and you're going to give us kind of an overview of a variety of different manufacturing techniques that you see out there and different technologies that you see in the build process. We've got Tim Lindquist with us from Framecad, and I think it was a New Zealand company. Is that right? A New Zealand company originally, or still, I guess?
Still is.
Still is, but and kind of a different approach to how we traditionally build here in the U.S. So he'll be giving you some insight to how they do things down under and maybe how we do things up here someday soon. We got Chris back with us. He was with us, as you remember, I think in the very first session that we had yesterday from Classica Homes. So he's going to be kind of opining on some of the things that he's hearing up here. And we've got Ross Maguire with Azure 3D printed homes. So we're going to hear a little bit about kind of the whole wild frontier of 3D printed homes. And I know Jason in Austin since he was a college student and lived in a dumpster, the founder of Icon. So I've been following 3D printed homes for a very long time. In fact, I introduced him to Lennar for the very first time and now of course they got that whole subdivision going. So that's kind of fun. So the question is advanced building systems, are they fad or future? You know, there's a lot of buzz about advanced building systems, and there has been for some time. There's a lot of hype out there. There's a ton of venture capital investment over the last, 5 to 8 years that have been pouring into this field. There's been huge plays out there like Katera, where we had almost $2 billion invested. Massive commitment to the industry. We have people like Integra, who was investment even from the industry, with Louisiana Pacific being a large investor in Integra, again, raising hundreds of millions of dollars. Just recently, we had Vive, which was funded by Fifth Wall, but also by Lennar and a bunch of large home builders. But all of those companies ended up going bankrupt. So money is obviously not the answer here, because we've had companies that have had access to hundreds of millions, if not billions of dollars in capital. And unfortunately, none of them have been able to change how we build homes. My guess is you're not building homes like any of those guys are, Chris. Nope. You're still doing it traditionally. We got a frame pack and it's being delivered and we're building it. Maybe use trusses, maybe use some wall panels, but it's a pretty traditional process that hasn't changed very much. So you might think, well, this whole thing is dead. Well, what I'm going to try to do is set the stage here of why it's not dead. And for me, the motivation for change always comes around the issue of profitability, headaches, shortages, timeliness and completion, labor savings, and fewer trades to manage. If you can do one of those things, then there's an opportunity to build better. And what we see kind of in our industry is that boils down to waste, availability, and customer acceptance. And in waste, we waste time. That's the very first commodity that we waste. Next, we waste labor. Then we waste material. and we have quality and rework problems on top of that. So all of those are opportunities for a new system to come in and have a substantial impact on the quality of the product that we deliver out there. And just to show you how bad this is, we'll take time as the very first thing. There's about 168 hours a week available to make things. Unfortunately, we're on site only about 40 to 72 hours a week, given the constraints that we have for municipalities and also the individual communities, which means immediately we only use 24 to 43% of the time that's even available to build product if we're building traditionally. So right off the bat, we waste anywhere from 60 to 75% of the time that's available in construction. And time is money, because obviously all of this is, you have to have financing for construction projects. Then on top of that, with the fact that there are days where no trades are assigned, there are days that are no-shows, there are weather delay days on top of that, that actually then breaks it down to traditionally for a normal production builder, they only use about 15% of the time that is available to them. So of the 168 hours a week, we only use about 15% of that time to actually do value-added work on site. So about 80 to 85% of all the time that we are given to start a project is completely wasted by doing non-value-added work or not by doing work at all. So we kind of start the clock at that rate. The next area is then material utilization. And the traditional home in the United States uses anywhere from 2 to 3 haul-off dumpsters. These are, generally, 20-foot or 40-foot type dumpsters. They're hauling these things off. All of that was material that we just bought. I can attest to this because I had an environmental waste management business at one time, and our job was to grind all the organic material on site. So you'd take all the drywall and you'd take all of the lumber products and you'd grind it on site and you just work it back into the soil as a soil amendment, and you wouldn't have to pay to have it hauled off. The contraption that was made looked like a huge grinder. It had a 6-foot long bed, 3 feet wide, and you put everything in it and would grind it up with carbide teeth, and it would separate all the metals, and dump them back out. And it was a great process. The number one problem that we had on site was sawing up 12-foot lumber and 4x8 sheets of plywood. Meaning at the end of the construction cycle, there would be 6 4x8 sheets of plywood there, and we would literally be cutting them into strips and throwing them in the dumpster so we could grind them off, because that's the waste that comes out of our traditional construction project. This is not, unusual for us to see this anywhere between 2,000 to 3,000 cubic feet of disposed waste per home. One, that costs us money that we have to get rid of it. Two, it's material that we just bought. Right? And part of this is the construction process. We're buying general dimensional material, not specific material designed for what we're building. Right? We bring it to the site. We, on the site, make decisions of how we're going to cut sheets of material, right? What cutoffs we have. We don't have any plan to reuse the material generally. Most of our takeoffs are not very good in the industry. In fact, we automatically pad everything that we send to the site because we know there's going to be waste on the site, which only encourages our people to waste that material. So we kind of work this cycle. Now, on the very other hand of this, when Clayton Homes builds a 1,200 square foot manufactured home, there is a total of 2 32-gallon trash cans of waste in the entire factory. 2 32-gallon trash cans of waste. And the reason for that is they don't buy dimensional lumber in any size, and they don't just cut the boards any old way. They use every single piece of material they can, even to the point where they go, these little cutoffs on this wood here will be used for blocking over here, and they actually have a transportation path to be moved to the next section of construction where they're doing blocking. They have a complete layout of all this. What it allows them to do is build an incredibly efficient home. So the opportunity, first of all, that we only use 15 to 20% of the time that's given to us. We throw away 2,000 to 3,000 cubic feet of material that we have just bought and paid for and thought was really great material to begin with. So about 10 to 20% of the direct material that we use is either thrown away, is over-ordered, and not consumed necessarily in the next job or damaged during the construction process. And then the very last issue here is our aging workforce. Our workforce is under demographic attack, and that's probably the best way to say it. We have an older workforce. You can see from this chart, we have more people retiring than we have entering the workforce. This is causing us to have more and more job openings. It's getting harder and harder to find trades in the space. And this is exacerbated, obviously, in some markets, that are growing faster and have more building. But this is happening all around the country. You talk to builders in Rhode Island, you talk to builders in Oregon, you talk to builders in Minnesota. They all are suffering from this general lack of abundance of skilled trades. So we have an opportunity here if there are new techniques which can either improve the efficiency of material, improve the efficiency from a time perspective of how we use our time and can get to start to finish more quickly, or we can figure out a way to use less skilled trades or our people more efficiently. It bodes well for us to be able to find and build a bright new future. So to me, the future of home building lies somewhere in this combination of things, whether it's components, sub-assemblies, that are potentially being made 24 hours a day, 7 days a week, in a conditioned space and being sent to the job site, so the amount of labor on the job site is less. That could be it. Or it could be complete modules and it doesn't mean the entire home has to be modular. It might be that we get modular bathrooms, or we get modular garages, or we get some component of the homes that are actually come to us in complete modules. Volumetric build has made great strides, and there are already significant markets in the United States that are using volumetric build very effectively because they simply don't have the trades. Think the Florida Keys, think Colorado ski country, where your closest trade is probably 2.5 hours away, right? These are markets where volumetric build just makes sense, and there are companies out there taking advantage of that. Additive manufacturing, which you're going to hear about, that's what I call 3D printing, right? Because it's really additive manufacturing, a whole different, very material efficient and labor efficient and clock efficient process, right, to building the structure. But also there's issues of robotic specialization, human augmentation, even advanced materials that we're seeing in our industry that could potentially change everything. So with that, I'm going to turn this over to Paul Cardis, and you're going to take us on a whirlwind tour through a whole bunch of different technologies.
Yes, thank you, Tim. Appreciate that. That was awesome. Always love your keynotes. So we got a mini keynote here from Tim.
Mini keynote. There you go.
It was really perfect.
I'll charge John for that.
You charge John for that. Yeah, he owes you. That's really, really well done summary of where we're going. And so I'm just going to expand on that just a little bit and talk about what we're seeing on our end of it. And so our company is On3, and what we're doing is we have basically a frontline knowledge platform. So we're documenting all the how-tos in the business, and we're serving that to builders, trade contractors, and building product manufacturers. So we're getting to see a lot of the inside tracks of companies doing some pretty cool things. And so I'm going to talk about basically tying directly into what Tim's saying here, robotics, materials, and human performance. Those really are the key areas that we're going to explore. And the first I want to talk about really is this area of kind of robotics and essentially the new way that we're looking at. So one of the companies that we talk about is Icon. And so just to have a quick little video, we work with them in terms of capturing what they're doing, and they're doing some amazing stuff. If you haven't seen their stuff before, it's pretty cool.
Now, Jason Ballard, who's the founder of this, I've known him for a long, long time. When I last met with him at South by Southwest, he claims that they can now build an entire exterior wall structure for $28 per linear foot, which is supposedly 10% less than the average cost of an exterior wall structure from traditional build, meaning studs, OSB, wrap, siding, et cetera, et cetera, et cetera.
Yeah, that's really it, right? We've got to get that. The cost of this has to make sense. It has to pencil business-wise before this really takes off. So I'm real curious to hear from some of the other companies. This is just one of many, right? And this is an explosion, as you pointed out. And what I think is cool, too, is they're pushing the envelope, too, on what we might build with. And so I also wanted to mention that they earned a large NASA contract to actually build homes on the moon. So if you haven't heard about this, this is great. You know, this is our industry really doing something that the whole world will be looking at. So we'll just take a quick peek. I think what's so cool about it is using an innovative material here to actually make a structure. So this is actually moon dust that they're taking and melting.
Yeah, on top of that, they also have just released a new low carbon footprint chemistry. Yeah, everybody thinks they're printing with cement. It's cementous, meaning it's a cement-like material. And one of the hits, of course, that this takes is the carbon footprint of cement, because cement has a horrific carbon footprint all by itself. So they have invented and are now deploying a new low carbon cementous material to be used in all of their printing applications. So we'll actually have a smaller carbon footprint than using a traditional wall cladding system as well. So
Yeah,
kind of interesting.
it is. It's tremendous, and what they're doing there to innovate and really, go beyond traditional techniques is awesome. And this is just a snapshot of what's happening. There's so many other companies. We could just spend hours looking at all the new companies, and we're going to hear from one of them here in a bit. But the point here is that the game is changing, and it's changing fast. And we're getting some of the industry, not even the industry, the world's leading minds to do innovative things in construction. So the old 2x4 that we've been building with now for well over 100 plus years, that's probably not going to be around, in the future. We're going to find better, cheaper, faster ways, and housing affordability is going to drive this. So because we just can't build it the way we're doing with all this inefficiency. The average homeowner today cannot finance the average house. I want you to think about it. I just published that here on LinkedIn this week. So if you take the average salary today, see their take-home pay, it crosses the 50% mark, which lenders won't give you the money. The max is 43%, and they probably stretch that a little bit. So now that we've crossed over to 50% of monthly income required to pay a mortgage, yeah, they can't buy an average home. So we're going to have to make big changes, and I think products like this are going to be really important, or different techniques, and we'll continue to explore that. But the other piece is the materials that you had mentioned. And so just some insights into some cool materials. And this one too, again, we could spend a whole conference talking about all the cool materials that are coming out. But I just grabbed a couple that we happen to be working with, which is great. The first one is Span. I don't know if you guys know the Span product, but they're pretty much, revolutionizing the whole internal electrical system and foundational structure that we have within a house. And so this is actually going live in a Pulte house that they're using. And so Span.
Welcome to your Pulte home, equipped with a Span energy management system. Your home will use electricity generated by the solar panels on the roof, and you'll be able to store extra energy in your home battery in the garage. And because you'll also have Span, the smart electrical panel, your home is equipped for the best in comfort, savings, visibility, and control. And the choice is yours. By choosing between automation and manual settings, you can take as much or as little control of your home's power as you want. Span centralizes your energy data into one real-time dashboard, giving you a 360-degree view of where the power goes. Even though you also have apps for your solar and battery systems, Span centralizes it all for you. Smart monitoring provides visibility into your home energy, allowing you to track every last electron. As energy costs increase, Span can help you find ways to take advantage of off-peak energy pricing. Your home is ready to buy low-cost electricity and store it to use at high peak times, Uncover patterns in your home's daily energy use. SPAN provides recommendations to optimize for energy efficiency, cost savings, and more. SPAN extends your home battery backup duration by 40% during an outage and gives you precise control over your stored power. SPAN gives you full flexibility to change what rooms and appliances receive power in an outage, so you can keep the power on where it's needed most. Your new home will be ready soon. Until then, download the SPAN Home app. We've included a demo home called the Watts Residence for you to see, and use the functions that you will have in your new home. When your home is ready and you meet with your Pulte representative, you will receive a specific email invitation giving you full control over your home's electrical system.
So these technologies are going to change the way we're wiring houses, the way we're basically even thinking about how we operate houses, and I think this is going to have to be factored in as well as we look at the energy changes that are coming as well. But this goes beyond just looking at, the electronics of it. We also have a bunch of structural stuff. So, for example, insulation. We're seeing more bib insulation. And so one of the companies that we're working with specializes in that. This is a trade contract.
We'll talk about Intello and some of the details as far as the install goes. So this is the product right here. It's very rigid as far as a sheet air barrier goes. It's extremely strong. It's actually meant to be installed and blown behind. We don't actually do that. We hang a bibs fabric up first, blow our bibs fiberglass into cavities, and then go over the top of that with the Intello. So a few details with the Intello. It hangs just like any other sheet plastic or sheet good wood. We keep a nice straight start along the top, and then pull this product down in the center and tighten it left and right from the center.
So I'm just going to mute that for a sec. So the idea here is that we're going to be changing the way we're doing things, the way we're applying materials. As you can see, this trade has decided to take some liberties with this particular product and apply it their way in their region. And then,
Not a good thing.
yeah, could be good, could be bad.
Could be good, could be bad.
Right. Different environmental conditions. They're actually very good at what they do. They're very known for what it is. But in their part of the country, that applies. You wouldn't want to do that in Florida. He happens to be up in the northern central area, so that works for him. And possibly works well for the builders. But so we're seeing how materials get applied also is going to become very specific and varied in various areas. That's one of the things that we're covering, is documenting those differences and making sure the trades understand that, and the builders and everyone involved. And so materials are going to go through, I think, a big evolution. And the last phase of this is human performance. That's just where we're leading to. Having these videos and all this different content is great, but we have to envision kind of how they're going to be used. And so AI is now coming into the construction frontline, and we're leading that right now with On3. And the old saying, AI won't replace humans, but humans using AI will replace humans. So when you think about, what's going to happen, how structures are built, that's going to be the next big shoe to drop. I think you're going to see now AI in the front line. And we're going to be making human performance better because it's supported with AI. Mistakes aren't going to happen. They're going to be tracked and caught in the field while they're going, and then we're going to be able to correct those instantly while it's happening. And in fact, we're already working on some of those solutions right now. So we're playing around with headsets that are worn with cameras. These are AI enabled. They can see what's happening, and not only that, they're providing guidance as well. So the glass in front of the worker's eye is actually like a monitor. Think Tony Stark, Avengers kind of meets construction. This is reality, this is what we're playing with in our shop. And using these knowledge components, these modules, we're able to now inform the AI of exactly, this is how we build it in northern Wisconsin. We seal the sheathing to the studs and create a cavity that's supported with the bibs and so forth. And now you can instruct that worker with that very detail in the field and as it's happening. And so this is, I think, we're gonna see that shoe drop as we bring new technology, new building materials, new techniques. All of that will get supported and become a reality, I think, through AI. It's the only way we're gonna be able to manage this, because there's over 7 million building products. We have thousands of different versions of building code, and we're building a house that has infinite number of failure points. And a human brain can't process that, but AI can. And AI, I think, will become a pivotal part of where we're going in construction.
So you mentioned materials as you get into this section. There's a company out there called Inventwood. I don't know if you've looked at them. They were a spin out from University of Maryland's forestry school, and they have a product now called Steelwood. And it has 80% of the strength of steel, but it's a 100% wood product. And of course it weighs, 30% of, or 20%, I guess, of what steel would weigh. So you don't need cranes. You can, do normal manual assembly. It eliminates the need for I-beams above garage doors, I-beams across large spans, and it's a 100% wood product. And it's all about the chemistry of wood. They're going into the science of the lignin in the wood and modulating the lignin and extracting and compressing and creating new products out of this. And this will change how we build someday.
Yeah, and how that gets fastened is probably going to be a whole different, possibly, way than the old standard nail, I assume. That'll be interesting.
Chris, I got a question for you. You look at all these crazy things. I showed you Integra, and I showed you Katera, and Vive, and now, Paul showed you a whole bunch of other things. Well, what's on your radar of something that you're trying to look at as a regular, everyday builder trying to build, house after house, reliably, predictably? What's on your radar to kind of look at from an experimentation perspective of the next step?
Yeah, that's one of the reasons why I'm here, just seeing.
And if you tell me it's battery-operated power tools, I'm going to be super disappointed. Okay,
No, that's one of the reasons come to these shows to see what's out there to try to push ourselves a little bit. We're a traditional builder, truss roof, stick framed. It's seeing some of the technology is great, and some of the trying to manufacture panels, but we do a lot of changes and options, and there's panels out there, but when you have 40 different options in a house, will those get translated to the manufacturing? How does that get communicated?
It's just faster and cheaper to do it on site, in that case.
I think for our product, what we're doing, yes, but I do think going to panel, getting pre-made panels, I think that should be possible.
So for you, there's kind of an evolution. You've already made the switch to go to trusses, right? And some builders haven't even done that, but you have made that. So the next thing, maybe walk down that panelization process.
Yeah, that's kind of, for me, kind of the thing to start looking at, because you're right, there's dirty, muddy lumber sitting on the ground after a house is done. You're like, well, that's $1,000 worth of material just sitting there that can't be used.
So panels are changing a lot as well. In the springtime, we had a guest from Diamond Age, which started as a 3D printing company here, not here, but in the Phoenix area. But they've abandoned kind of the 3D printing, and what they really got into was automation. And they have a one-man automated cell that creates 8 to 10 foot tall panels of any length up to 20 feet long. But what's different about it is they're fully loaded. All wiring and all plumbing and all insulation, it's already loaded in. So it kind of takes panels to kind of another level, right? Which, well, if you get them fully loaded, now I don't have to do all of that other stuff. And that's kind of their view of the industry of how do we make it easy for builders to take that next step. Well, let's kind of build like they do, but let's do a bunch of it in the factory 24 hours a day, 7 days a week with a lot of automation and no material waste, and just ship them to the site.
Right.
Now, I think that's to me, it seems like an easy next step for a builder to start experimenting like that.
Well, I would agree. And, just some of the new things, the training, the, new technologies, people aren't used to it. It takes a minute. So someone like yourself that can allow or provide information. So all right, we're going to use this technology. We can go somewhere to find the information to try to do it right, because the way we do it southeast is not the same way it needs to be done up north or out here. So
well, that's a good transition, because not up north or northeast, but way down under, right? They build homes way differently than we do, and a lot of that's because of Framecad. So Tim, why don't you tell us how they do it down under?
Yeah, I'll share with you some about New Zealand. I'm not from New Zealand. I'll just set that out there right away. But
can you do a New Zealand accent, please?
I cannot. Ross might be better at it than I. But But yeah, my name's Tim Lindquist. I'm with Framecad. We are a New Zealand-based company headquartered in Auckland, New Zealand, but we have a global presence. We have 1,000 machines, over 1,000 machines in operation around the globe in 120 different countries. So whether it's the Middle East, Africa, Europe, America, South America, we're across all of them. I'm going to talk about designing and building with cold form steel, and I guess kind of the theme is it's not as hard as you think. I know for a lot of people, steel might be kind of an intimidating thing if you're used to the timber world, but I guess by show of hands, has anybody used cold form steel in framing, in residential? Whoops, let me qualify that. Okay, cool. So 1 out of the room, that's great. 2. So it's just I'm going to talk about how it's not as hard as it may seem for those that are used to timber framing. And the picture you see on the screen here is from one of our actual customers down in the Dallas region, Net Z Homes, and their name is short for Net Zero. Mm-hmm. And they're really focused on how can we build net zero homes through HVAC systems, through the assemblies of the walls, installations. How can we really build energy efficiency homes? And for them, steel has been a big component of that.
And of course, you got 2 huge advantages. You're using recycled product, right, which is nice. And then 2, you're net roll forming it, so there's no waste.
Right.
If you needed 11 feet 3 1/4 inches, you're roll forming 11 feet 3 1/4 inches, and you're not cutting anything off. You don't have any scrap. So you have the ability to, in a way, do kind of net shape manufacturing, even though you're roll forming it.
Yeah, one of the biggest things that I like the statistic or the data point where you talk about building like a 2,000 square foot home and you're consuming 70 to 75 large mature trees. Mm-hmm. You convert that to steel framing and you grab 6 old Honda Accords off the road and throw them in the recycle, and you got yourself a home. So
like that.
Yeah, I always like that because I like trees. I like to look at them. I've built with timber before.
But you don't like Honda Accords.
No. Civics, that's what we call ones. Camrys, we'll call them whatever. We won't discriminate. Yeah. But yeah, so a lot of what you talked about earlier, Tim, we see it with our customers too. When we're having these conversations on the front end with different builders, different contractors, talking to them, what challenges are you facing? We face, they talk about all the ones you see on the screen. Workforce challenges, aging workforce, lack of skilled labor, across the board. We see them all, safety, compliance, all these different things. And so the question that we always ask is, what are you going to do about it, right? Like, if you want your business to remain, to sustain, to thrive, to grow, you have to change. And fortunately, we're in a position at Framecad where we can help with some of that, and we can help them go to the next level of their business if they're wanting to go into steel framing, of course. And just briefly, cold form steel might be a new term for some, might not be, but it's pretty self-explanatory. It's a process of forming steel at room temperature versus hot rolled sections that are formed at an elevated temperature. And because we deal across the globe, we speak a lot of different languages, terminology. Some people refer to it as light gauge steel, some light steel framing, LGS, LSF. It's referred to as a lot of different things. So benefits of cold form steel in residential and mid-rise. We deal a lot more in mid-rise, honestly, now here in the U.S., down in Australia.
Is that because of structure and fire and the codes required for that?
Yeah, it has a lot to do with codes, and it has a lot to do with, sorry, Chris, but stubbornness. I think there's, ways, people don't want to change from residential.
Agree.
Timber is just the way it's always been, right? And they're just not quite to the point where they've had a compelling reason to change to steel. And mid-rise tends to fall more in the commercial sector, which has long adopted cold form steel, and it's just been more commonplace. But down in Australia, when you look at it, 1 in 4 homes in Australia is being built out of steel, and of that, we're fortunate that we have a big market share where our customers are building about 20% of that 25% is being done off of Framecad machines in Australia. And it's driven down there by, what they're facing. They face a lot of brush fires. They face a lot of adverse conditions that, steel makes a lot of sense for them. So benefits of the cold form steel, durability, again, termites, fire resistance, seismic, mold. We don't have a piece of lumber that's out there in the mud and then going into a wall cavity before it's dried, before it's, and potentially, releasing moisture in there and molding, doing all these things. And really it's, ensuring the long-term integrity of the structure itself. Homes are kind of, for a lot of people, it's a very intimate process when they're building a home, and they love the home and they spend a lot of time in the home. And I think if you can tell them, hey, this is going to last you a long time, they like that. Cost effective, again, we've talked about material waste. So producing exactly what you need, only the length that you need, not having excess, you're saving money there. Eco-friendly steel is 100% recyclable. And, there's a reduction of the carbon footprint with that. Engineered exactly to specifications, so it allows for a lot of different architectural design styles. So if you want wide open spaces, you can do a lot of that in steel, advantage over wood. And a neat fact that I like, strength to weight ratio. So a lot of people are concerned because they pick up a metal stud and it's kind of flimsy, it's kind of flexible, it's not a solid chunk of wood like you're used to having. But when you look at it and you think about, your standard 2x4 12 gauge stud, because we measure everything in gauges of, steel thickness, that stud can hold 8,000 pounds of combined axial lateral loading, and it only weighs roughly 20 pounds. So a tremendous strength to weight ratio. And then, that weight compounds down too, where now when you've reduced the self-weight of the building material, your foundations, everything below is not supporting that and can be reduced. So that's cold form steel. Framecad, I'll just touch on this. As I mentioned, we're a New Zealand-based company. We're a global presence, but we do have our North American headquarters in Las Vegas. So we service all of our customers, and we don't actually produce any metal material. We're not a stud supplier. We're not anything like that. We provide the technology to builders, to framers, to all these different groups so they can go and carry their business of construction. So Framecad's role in CFS framing, we have design and manufacture and then build, and those are the 3 points I'll touch on. So the design aspect, this is a super critical part of it, and everything starts with the design. So instead of kind of having a design done and then having trades on site or people on site going out to build, the designer inside is now doing a lot more coordination in the BIM world, coordinating with MEPs, making sure that we have proper runs for HVAC, plumbing, electrical. It's all done inside of the design software to send a file out to the machine to make sure that that machine can produce accurately. Now, the software also does a lot of engineering. And so there's two different softwares with Framecad. And really it's focused on allowing the individual builder to input, engineering criteria. So if you know what your seismic loading is, if you know what your wind loading is, dead load, live load, all of these conditions, they can go inside of the software. Your designer inputs that. All of that calculation carries through in the software. So now you have an engineered wall assembly or an engineered truss that's ready to go out for fabrication. You can generate a report, an engineering calcs package that can go out to the structural engineer. They do a quick once over, give it a stamp versus them having to do the hard work of doing the actual engineering calculations. So it's designing trusses, it designs headers above doors, it designs, wall studs. And it also helps you economize the design. So you can really, play with different sizes, different stud spacings, different material thicknesses inside of the software. And, that's all done by the customer, all done by the home builder, the mid-rise builder, commercial contractor, whoever is utilizing the software. Secondly, software also has Detailer, which is generating shop drawings, 3D renderings, some panel layouts for the fabrication inside the facility or also out on the project site. So the manufacturing, the design gets done, now it goes out to the facility or to the manufacturing floor. And this is an example of one of our machines. And there's a whole bunch of different machines, so we're not the only one in the space. There's a lot of different companies out there as well, all built on relatively the same technology. But the machines are really geared towards how do we efficiently produce the materials? How do we accommodate this lack of skilled labor? How do we do all these things to allow this business to thrive, expand, do all these things? So the machines are cutting to length, they're punching holes in the studs, they're punching holes in the track, they're punching holes for your electrical runs. They're doing all of that very precisely with very, very minimal waste. All these little punch outs, they come and they collect in a bin. So you talk about the 232-gallon, garbage cans, it's probably similar, to what we would see, actually probably less, just purely on the framing for a 2,000 square foot home.
And how many people operate that? Because that's kind of it's a roll of steel at one end, and the other side, my building material is coming out, correct?
Right.
Now, that's coming out section by section, one piece by one piece off this machine, correct?
Correct.
So how many people to operate that piece of equipment?
So like a normal crew size would be one person that's dedicated to operating the machine, and usually 3 assemblers on the other side. And like, for instance, the machines will run 1,100 lineal feet per hour is what they'll throughput on a production mode. And that crew of 3 people is going to assemble like 400 lineal feet of steel coming out of it. So you can do the math, 2.5 crews can be consumed by one machine.
Gotcha.
So the efficiencies of them are...
And the assembly of the wall panels or trusses is all manual?
It is at this point.
Oh, are we learning something secret here? Did you pick up on that? I picked up on that.
No, I mean, in the world of robotics, it'd be hard to say that it's not like, in the future. And there's companies out there. We have been engaged with a few and exploring this. How does this robotic technology come into the cold form steel space? I think in the wood world, it's relatively easy. It's a solid piece. Now, when you have this C-shaped with an open edge, it's a little bit more complex, I think, for the robots to get it, to fit it, to put it in, to do these kinds of things. So it's taking a little bit more work and finesse.
Is the assembly purely done in factory off the back of the machine, or do you sell to, or do people work it in a way that they send those lengths to site to then be assembled on site?
Yeah, both ways. It's all a function of economics. If it's being shipped far away, if you're panelizing and putting it on a trailer, you're going to ship a lot of air.
Yeah.
And it's kind of a waste of money. Whereas if you bundle it together in a package, you can send it out to the site and do the assembly, right on the job site. And it makes, it makes the economics work out better in some cases. So, and I should step back too a little bit. From the design aspect to the machines, everything is code compliant. So like our company, we have ICC certification, which is the International Code Council. They've certified that the machines produce materials that are suitable for the building practice. So anybody that's producing the materials, sending them out to project sites, they can rest assured that they have that level of certification. It's a qualified building material. It's not some crazy thing that's out there just flying under the radar. Code officials come. There's the specification sections that work with all the material. So it's all compliant with that. And the building, so again here, once it gets to the site, you're not stick framing, you're installing panelized walls, you're installing prefabricated trusses, or you're installing what we refer to as a deep sea trade-ready joist that has a larger knockout in it to accommodate spiral ducting, to accommodate sanitary plumbing lines, different things of that nature. the big benefits of this, of course, we keep talking about, how can we reduce timelines, right? Time is money. How can we decrease the construction time, decrease carrying costs, all these different things. This type of construction really allows you to start producing when foundations are just going in. And when foundations are done, you're going out, you're installing wall panels, trusses, all of that. The reduced labor on site, of course, a lot of our customers that have changed from traditional stick framing to a panelized system, they see a 50% reduction easily of on-site labor. And then not only for the installers, but the trade people as well. So they're not running around, they're not punching holes through studs. All the holes that they need for the electrical are done. They're punched out on the machine, and they're just now able to go and run MEP through that. For the home builders that we work with, one of the biggest things that they talk about is this lack of callbacks, this lack of warranty work, because we're not talking about a wood member that's shrinking or expanding given the atmospheric conditions, the moisture, whatever, and they don't see drywall cracks. And I found that very interesting because I thought, I'd never would I thought like a little crack in a wall was, a big issue. But they talk about, not having these callbacks, not having these warranty.
No termites.
Yeah. And, the reduced on-site waste. It's shocking to see the numbers of 2,000 to 3,000 cubic feet per house. And when you go and you look at a customer like NetZ Homes and you go by their job site, and it's awesome and amazing to see like how clean it is. There's not piles of wood. There's not very minimal, trash, debris in the garbage, which is awesome. And then from the health and safety aspect too, not having that garbage, not having these trip hazards, not having all these different things on the project site. So cost, of course, is a big one. What does it cost, right? There's these stigmas, these myths about, well, steel is expensive. Well, it is expensive. Traditionally, it's more expensive than wood. But when you take into account all the different things that are achieved through the efficiencies of the design, the efficiencies of the manufacturing, and then the efficiencies of the build, we have many of our customers that have shown us where they've beat wood. They've beat wood on a one-to-one basis. They've beat concrete masonry on a one-to-one basis, especially in California's, the Florida's, the Texas, a lot of different markets where you're experiencing seismic requirements, you're experiencing hurricanes, you're experiencing termites, a lot of these different, and it's largely driven by insurance. So insurance costs have pushed a lot of people, or given them reason to make this transition as well. Again, mid-rise construction is pretty common, but single-family homes are becoming more and more in these regions prevalent to be built in steel. For homeowners, again, I go back to NetZ Homes, but they have a lower operational cost in the homes, well-insulated homes, stable homes. They sell that as a value to their customers. And as I mentioned, the insurance costs, we talk with some of our customers that see a 50% reduction in their builder's risk.
We mentioned it in our first session, Chris. We were in this whole issue of insurability because of the flood problems that we're having, the hurricanes, tornado problems, the fire issues that we're having all across, lots of different regions. We'll get to a point where we're going to have to build different just to make the home insurable, period. Agreed.
Yeah, and I think we're there in some ways, because we've had calls where it was a remote region of Utah, and we got a phone call, and they said, well, my insurance won't actually pay me out until I show them a building plan of a non-combustible building, because mine just burned down for the third time.
Oh, wow.
And so
There you go.
Yeah, I mean, you get different.
So you only get 3 strikes? Is that?
I guess it's like baseball.
There you go. Yeah.
So it's there in some ways, and we don't see it always because we're the supplier of the technology, but we do hear from our customers about all these challenges that they're facing, and insurance and all these different things. So that was a brief overview. I could talk for hours about it, but if you want to know more, by all means, come and find us.
So Chris, you're a traditional builder. You don't do steel at all.
Nope. other than that.
But you've heard his pitch. You think you could even get yourself to think about maybe experimenting with something like this someday?
Get ourselves to thinking about it.
Oh, well, there we go. That's progress. Can you come up here and help him get some?
No, it's intriguing. I will stop by the booth, as you talk. I mean, I made a couple notes like, we know wood. I've been doing this for 25 years. We all know wood, and we know what wood does, and that's just, I mean, if we're going to frame in cold form steel to my company, I mean, what the hell are you
You're changing the medium, but you're still dealing with, trusses. You're still dealing with stud walls, right?
Well, I mean, it's not rocket science, right? But it's just, it is new and different, and to get your head wrapped around that. And when you're talking about wood, I had read somewhere, it's like if somebody came up with this new product, that was dimensionally unstable, and basically describing all the characteristics of wood. You're like, I'm not going to be building. I'm not going to build with that crappy material, but that's what we, drywall cracks, and just movement of the house. So it's definitely something intriguing to look into a little bit more as far as the possibilities, and with the sustainability and lumber and all the other, the trees, like you said. These are the directions we need to be going to look at new innovative ways to do things. And some of those companies you said are out of business. People are trying new things, and they'll getting it thrown up against the wall. Sometimes it sticks, sometimes it doesn't. But out of those trials and errors and failures come new things, and you try something else. Like, well, 90% of this didn't work, but 10% did. So we're gonna take this 10% and try something, something new. And
well, it's interesting because some of the people at the NetZ homes are former Katerra people, right? And so they took these pains of previous lives and learned and said, let's not do that again. And they've now modified the processes or how they go about things to.
So that's how I think the industry is going to go. Is just these little things they keep changing, and there's a need. So people are going to keep looking for things that are going to work.
Well, we're going to step it up a notch. We're going to go one more. We got another presenter here, Ross, and we're going to step it up a whole nother notch to make you feel even more uncomfortable, Chris. Okay?
I don't
Sweating a little bit on it.
I don't stand a chance with Chris if steel studs are a step too far. Because, so I'm Ross Maguire, CEO and co-founder of Azure Printed Homes. We've been around for 5 years, my business partner and I. Actually, let me go a little bit further back. So I have to introduce my accent usually first. So I'm from East London originally. I've been in the building industry all my life. Used to work on building sites, digging and wheelbarrowing around in my school holidays as a kid. And then ended up doing a master's or degree and master's in civil engineering back in the UK, and moved straight back into frontliner construction. So I worked for a large GC in and around London for a few years, worked on some fantastic projects. The NATO headquarters just outside of London in Northwood, worked in a nuclear bunker, which was pretty unique, building and cutting doors through EMP shielded rooms and all sorts. So had great experiences straight off the bat there, and then decided after a few years I was ready to start my own company. So I was a GC in and around London doing commercial and residential remodels and new builds. And then met my now wife in 2016, who's American, came here in 2018. And my business partner, Gene, was running a GC in West LA at the time. And we met and kind of had a lot of synergies on a lot of the things that we believed in, and decided to start Azure Construction in 2019, shortly after the Woolsey fire that we experienced in Malibu around that time. So we started predominantly in building new homes more traditionally, stick build with a few innovative processes to rebuild some of the homes that were lost. And the ADU law here in California had recently changed around the same sort of time. So we're kind of busy across two fronts there. And then, as we all know, COVID came, which I like to often say that I actually had 2 COVID babies. I have a 2-year-old and a 4-year-old now. But this is what I class as my third, was what we conceived like as an idea at the beginning of COVID.
You're in trouble because COVID comes around every year.
Right, yeah. A new one, yeah.
You're going to have a family of like 19 here pretty soon. Okay?
Startups, yeah. So yeah, we had the idea back then, and I've got a few slides that are very similar to the ones that you shared at the beginning there, Tim, almost carbon copies, because what inspired us to try and come up with something completely new and alternative was a lot of those pain points that you shared at the very beginning. So I mean, this is a kind of short timeline over the last few years, but we whilst we were building more traditionally and we had kind of revenue through that, we had our side project of let's do our initial R&D, and eventually printed our first prototype at the beginning of 2023, and then 2022, and then we built our first printer. Ideally, we wanted to buy a printer off the shelf that could achieve exactly what we wanted to achieve. That didn't exist. So we had to custom build our printer, which we completed the first one beginning of last year. And now we're in a larger facility beginning of this year with 3 printers running not far from here, down in Gardena, just on the way down to Long Beach. So yeah, to rewind, don't look at this one, Chris. The reasons that we wanted to, as I say, we're in the middle of it during that period of time ourselves, and with COVID, people were trying to work from home, trying to have a remodel or have an ADU added to their home whilst they're trying to take Zoom calls in the house, and you've got this. I mean, you're in a pretty heavy relationship with a client when you enter a building contract, regardless. But when you add in those factors of people trying to work in and around a construction build going on, it's even more difficult. So for us, taking the process off site was rule number one. Around the same sort of time, companies like Icon and others were becoming more and more popular, but we wanted to approach things in a slightly different way, in that we didn't want to be relying so heavily on a cement-based product, and also we wanted to be able to print. Obviously, we want to take it off site, so printing in factory, not having to rely on if it's too hot, if it's too cold, if it's too wet, if it's too windy, and being delayed on site for problems that we already know about. And also the efficiency of, my perspective was, if we're going to 3D print something, let's kind of give it more and more responsibility, not just to say take away pouring concrete walls or block forming walls, and to try and add more and more responsibility to it. Almost the same picture that you had, but we all know the amount of waste, the amount of overflowing dumpsters that come off of our sites on a daily or weekly basis, and that added with the fact that the waste that we do send away, I guess I was naive in the beginning before I kind of got into this, thinking that even though it's going in a dumpster, there's someone at the other end that's kind of sorting through it and it's getting recycled, and we're going to see it at the other end.
Oh, nope.
Particularly with plastics and polymers, I was amazed to find out in the early stages that only 6% of all the plastic waste we send to be recycled actually gets recycled here in the States. So all of those here in LA, all those blue bins that we fill up, we think are heading off for a new life, but ultimately they're getting 94% of them are getting buried in the ground, which constitutes about 32 million tons here in the States each year. So our approach was to kind of bring all of those things, all of those frustrations and pain points into one automated product. So mentioning about the efficiency of how we're applying 3D printing, it was let's print something that's more than just exterior walls to a home. So the concept, the vision was printing, and I'll show you a video of our printing in action in a second, but printing a module in factory conditioned environment on its side, so that we're then rotating in 90 degrees and we suddenly have a 4 sides of a 6-sided shell, which forms more of the structure, but also allows us to connect in a modular fashion to create larger floor plans and more of a kind of volumetric traditional process. Obviously, our biggest efficiency in all of this is that we're printing that shell. It takes just 24 hours to print. And so that framing, that sheathing, the paper, the exterior finishes, the roof membrane, the roof finish, the flashing between the two, all goes away into one automated 24-hour print. The rest of the process is our assembly line, where we complete each unit, regardless of its size, to the point that it's ready to ship and connect to foundations and plug in and live in immediately. So we do also provide each unit to be entirely off-grid if customers choose, so they can be solar powered and solar batteries, inverters inside the unit, so that they can be entirely self-sufficient, so you don't even need to plug them in once they get to their location. And each one of our 180 square foot modules, we utilize the equivalent of around 100,000 plastic bottles. So we have our own blended composite, which is largely polymer waste. We have a large proportion of fiberglass and other additives that we have tested and certified for the durability and strength that we need. Once the print's complete, we then coat the exterior in a intumescent Class A fire-rated coating, and then a UV coating, which gives us a 20-year warranty on UV protection and color protection on top of the unit as well. Obviously, the fact that we are largely composite, UV is effectively our biggest thing that we need to defend against. So that coating has to be reapplied every 15 to 20 years, so really no different to any other home. I think I've got a video on the next one. So this is our factory in Gardena. So we apply more of a lazy Susan approach to 3D printing. The table rotates, and the robotic arm with the extruder lays layer by layer. This one is a 9 by 20 foot module, 500 layers, takes 24 hours. We build everything electronically in model form first, so that we can CNC and have everything automatically made to measure, so that it is more of an assembly line rather than a construction line to take our units to completion. So right now our process kind of works that our B2C customers can go to our website, and we've built a configurator on there where they can customize their finishes, updates the price in the right-hand side of their view, and they have effectively a cart that they can fill for the design that they choose. As I mentioned, it takes 1 day to print. Then depending on the module size, it takes 4 to 15 days. If it has kitchens and bathrooms inside, and the number of modules stretches out to 15 days. And then depending on where we're going, which we've delivered across the country so far, and here in California, can be 1 to 2 days. And then installation is generally a module per day. There's a few of our units going in, so they can be either craned or forklifted, similar to any other volumetric module. And then foundation-wise, it can either go onto this is a installation up in Big Sur that we did that's entirely off-grid. Goes onto a stem wall foundation. We have hold downs already fixed into the exterior walls of the module, and then it's just utilities to connect. You told me about this on what was it, Monday? So I threw this together quickly. Probably not, but yeah, that's a kind of high-level summary of our product and what we do.
I bet this makes you sweat a little bit more thinking about 3D printing a plastic shell of a building and having it sent to your site and hooking them together.
What size can you do? Like
The module size at the moment is limited to our table size, which is 9 by 20. So we just do modular connections between each one for the larger floor plans.
you do 2 stories?
We've just engineered it for single story right now, but yeah. So
I'm not too worried
about
about too.
R&D. Yeah.
No, but it was great technology, especially in the tiny house movement was cool. Going on to
ADU, backyard ADU type thing. Yep.
Yeah, exactly. No, it's great.
Yeah.
All right. Well, Taskmaster here says we got 14 seconds left, so we are going to conclude this session. I'd like to thank these speakers for giving their time. If we could give them a little hand. Thank you very much.